was created.
Finally, done making macros.
Create global function binding call would succeed if called for the same argument n. Create global var binding n d used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding n v d create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument d is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N, the has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, return true. Let objrec be envrec. Return objrec has binding n, 1, 1, 4, 2 create mutable binding n d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, throw a type error exception. Return dclrec create mutable binding n, d, 1, 1, 4, 3 create a mutable binding n, s. The create immutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, throw a type error exception. Return dclrec create a mutable binding n, s. For initialize binding n, v. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let dclrec be envrec. If dclrec has binding, n, is true, then a return dclrec initialize binding n, v. Assert. If the binding exists, it must be in the object environment record. Let objrec be envrec. Return objrec initialize binding n, v, 1, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n, is true, then a, return DCL-rec set mutable binding, n, v, s. Let OBJ-rec be env-rec. Return OBJ-rec set mutable binding, n, v, s, 1, 1, 4, 6 get binding value, n, s. The get binding value concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding throw a reference error exception. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n, is true, then a, return DCL-rec get binding value, n, s. ECMA International 2024 145. 3. Let OBJ-rec be env-rec. Return OBJ-rec get binding value, n, s, 1, 1, 4, 7 delete binding, n. The delete binding concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCL-rec be env-rec. If DCL-rec has binding, n, is true, then a, return DCL-rec delete binding, n. Let OBJ-rec be env-rec. Let global object be OBJ-rec. Let existing prop be has own property, global object, n. If existing prop is true, then a. Let status be OBJ-rec delete binding, n. B. If status is true and env-rec contains n, then I remove n from env-rec. C return status. Return true, 1, 1, 4. 8 has this binding. The has this binding concrete method of a global environment record env-rec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 4. 9 has super binding. The has super binding concrete method of a global environment record env-rec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record env-rec takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record env-rec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return env-rec. 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9, 1, 4, 1, 2 has var declaration, n. The has var declaration concrete method of a global environment record env-rec takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be env-rec. If var declared names contains n, return true, return false, 1, 1, 4, 1, 3 has lexical declaration, N. The has lexical declaration concrete method of a global environment record env rect takes argument n, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called let dcl-rec be env rec return. dcl-rec has binding n, 1, 1, 4, 1, 4 has restricted global property n, the has restricted global property concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let objrec be env rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined, return false. If existing prop is true, return false. Return true, the 1st of April 2015 can declare global var. N, the can declare global var concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument and redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called let objrec be env rec, let global object be objrec, let has property b, has own property, global object, n, if has property is true, return true. Return is extensible, global object. Note properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147, 9, 1, 1, 4, 1, 6 can declare global function, n, the can declare global function concrete method of a global environment record env rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument and it performs the following steps when called let objrec be env rec, let global object be objrec, let existing prop be global object, n, if existing prop is undefined. Return is extensible, global object. If existing prop is true, return true. If is data descriptor, existing prop, is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding, n, d, the create global var binding concrete method of a global environment record env rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called let objrec be env rec, let global object be objrec, let has property b, has own property, global object, n, let extensible b, is extensible, global object. If has property is false and extensible is true, then a perform. Objrec create mutable binding, n, d, b perform. Objrec initialize binding, n, undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d, the create global function binding can create e method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8 replaced. It performs the following steps when called: let objrec be envrec, let global object be objrec, let existing prop be global object. N. If existing prop is undefined or existing prop is true, then A. Let desc be the property descriptor. V. True. True. D. Else A. Let desc be the property descriptor. V. Perform. Define property or throw. Global object. N. Desk. Perform. Set. Global object. N. V. False. If envrec does not contain N, then A. Append N to envrec. Return unused. 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy, will produce the same sequence of proxy trap calls. 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for getBindingValue, deleteBinding, hasThisBinding, and getThisBinding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1. 5. 1 getBindingValue. N. S. The getBindingValue concrete method of a module environment record envrec takes arguments N, a string, and S, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is N. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert. S is true. Assert. Envrec has a binding for N. If the binding for N is an indirect binding, then A. Let M and N2 be the indirection values provided when this binding for N was created. B. Let target env be M. C. If target env is empty, throw a reference error exception. D. Return target env getBindingValue. N2. True. If the binding for N in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to N in envrec. Note: S will always be true because a module is always strict mode. Code 9. 1. 5. 2 delete binding. N. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding. N. M. N2. Create an immutable indirect binding in a module environment record. The string value N is the text of the bound name. M is a module record, and N2 is a binding that exists in M's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13. 5. 1. 1, 1. 5. 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1. 5. 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1. 5. 5 create import binding. N. M. N2. The create import binding concrete method of a module environment record env rec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called assert. Env rec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in env rec for n that references m and n2 as its target binding and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1 get identifier reference. Env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note, module environment records always provided this binding. AB, let outer be env. Return, get identifier reference, outer, name, strict. 9. 1. 2. To new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment, G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment, G, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields, field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names. A list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy NV. The abstract operation new private environment takes argument outer privy NV, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy NV. Names, 2, 1. 2 resolve private identifier. Privy NV. Identifier. The abstract operation resolve private identifier takes arguments privy NV, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy NV. For each private name Pn of names, do A if Pn is identifier. Then, I return Pn. Let outer privy NV be privy NV. Assert. Outer privy NV is not null. Return resolve private identifier. Outer privy NV. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global ENV, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and V, an array, F, the agent that owns this realm, the global object for this realm, the G, global environment for this realm, meaning, the intrinsic values used by code associated with this realm, a list of records, with fields are, a string, and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2. As mentioned in host load imported module 16.2.1. 8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9 3 2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm reg, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform add restrict. Add function properties. Realm reg. Return unused. 3.3 set realm global object. Realm reg. Global obj. This value. The abstract operation set realm global object takes arguments realm reg. A realm record. Global obj. An object or undefined. And this value, an object or undefined, and returns unused. It performs the following steps when called if global obj is undefined. Then, A. Let intrinsics be realm reg. B. Set global obj to ordinary object create, intrinsics, assert. Global obj is an object. If this value is undefined, set this value to global obj, set realm rec to global obj, let new global env be new global environment, global obj, this value, set realm rec to new global env, return unused, 3.4 set default global bindings, realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw, global, name, desc, return global. 4 Execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component, purpose, code evaluation state, any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function, if this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm, the realm record from which associated code accesses ECMA script resources, script or module, the module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component purpose. Lexical environment identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. env name strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator. The generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding, 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contain on an ECMA script language a value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called: let envrec beget this environment, return envrec get this binding, 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called: let envrec beget this environment, assert envrec has a field, return envrec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called: 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note 1: host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module. A script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, Job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: to host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158, ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. Callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 9, 5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org, for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org entry, concept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and